Welcome back to Let's Get Defensive, the show where we take a deep dive into modern science and health research, from nanotech health robots to AI-created vaccines, learning to hone our immune defense systems against the threats of a modern world.
Wrong show, buddy. Wrong show. This is Let's Get Defensive. Let's not get all health and conscious and things like that. So definitely wrong show.
Yeah, right. Sure. Yeah.
Yeah. I mean, let's go with I think let's go with Andrew's idea. I think that's a good idea.
So we're gonna be talking defense and some space and some commercial aviation. We've got about 10 great great articles that we pulled out of the Ethernet or the internet or wherever it is, and then we're going to break that up with a commercial breaks, which has got bags more news going on in defense, space, and commercial aviation. That's the show. Yeah. Please, everyone, jump in. You can abuse if you wish. You can ask questions along the way, or you can throw your thoughts into the chat. Either way, they're all welcomed.
So coming up, we've got Terma, Lockheed Martin, Dassault, Saab, Safran, AeroVironment, Boeing, Embraer, Seraphim, FDH Aero, and HII, and probably more. Let's just start at the start. Greg?
Start at the top. Yeah. Terma, Denmark's defense giant, is stepping up to modernize the Royal Danish Army's air defense with a very short-range air defense system. This is the first major order of a 30-year framework agreement between Terma and the Danish Ministry of Defense Acquisition and Logistics Organization. The new system is going to be integrating advanced sensors, including radar, with the Skyranger 30 effector from Rheinmetall. All of this is going to be controlled by Terma's proprietary software, the BMD Flex. The any sensor best shooter concept means any platform, whether it's on land, sea, or air, can detect threats and choose the best response to neutralize them. Obviously, their solution is designed to work seamlessly.
Okay, yeah, there lies the biggest challenge, isn't it? Yeah. It's that integration of diverse systems, ensuring you've got seamless real-time communication and decision making across all of these different platforms and sensors within any sensor best shooter
yes
framework. Yeah, that's the challenge.
Yeah,
I agree. That challenge is any sensor best shooter is pretty fantastic, and this is the first order of, what did you say, a 30-year framework that Terma and Dallo signed last year.
Yep.
It sounds like it's a big integration of advanced sensors with the entire system control with Terma's proprietary command and control software. BMD Flex is going to communicate through Terma's infrastructure. So for me, this one's going to be a focus on integration within the context of requirements, or maybe requirements within the context of integration. I mean, the any sensor best shooter approach, which allows any sensor mounted anywhere on the vehicle, ship, or aircraft to detect the incoming threats and quickly determine the most effective way to neutralize that. So it's got to communicate across different platforms, get very good response time into this defense system, collaborating with the other air defense systems, and make sure that it's able to do all of that collaboration and integration in real time.
That's your biggest challenge.
What are you going to say is a bigger one?
No, you're right. Focus on integration within the context of requirements. It's spot on, yeah. But I go another step further. Requirements are critical, but the real challenge for me is ensuring real-time data flow, decision making across all of these different diverse platforms. So that any sensor best shooter approach will only work if all of the systems can exchange data instantly and reliably in live.
Before you say the thing I know you want to say, Greg, do you remember last week Andrew made us a promise?
He did, and I'm pretty sure he's going to stick with it, right?
No, it wasn't really a promise, was it? Let's be honest, because when you're talking about this kind of stuff, you've got to go AI to start fixing a lot of this. Requirements management is part of it, absolutely, but it's not the core issue. For me, it's that ongoing real-time synchronization, the agility of your systems that's going to really define your success here. So only solution using critical thread overlaid with AI is unified systems integration and real-time data flow. Requirements management traceability, yeah. real-time data synchronization. You've got to get your change management working. But honestly, predictive systems monitoring is going to be the big one. AI can monitor all of your systems for potential communication or operational failures and prevent integration issues in real-time operations. You got to get that plugged in on top of the whole critical thread side of things.
Couldn't even make it past the first article.
Greg, you owe me $5.
Oh, okay. All right. Yeah. I'll Venmo you later.
Yeah.
Now, last week, I know we talked about the Philippines, but this week it's Peru that is going to be bolstering its Air Force with the purchase of 24 new fighter jets. Options include the Lockheed F-16 Block 70, the Saab Gripen, the Dassault Rafale. The deal will enhance Peru's ability to defend its sovereignty, address security threats. I mean, it's historic. The Peruvian Air Force aims to replace its aging fleet, of course, which includes Soviet era MiG-29 and Su-25 fighters. This is the first phase of a $2 billion project here.
24 jets, right?
Yeah.
They're looking at a selection of 24 jets made between Lockheed Martin, Saab, and Dassault. And all of these are really cool. So Lockheed Martin's F-16 is an advanced version of the Fighting Falcon. It's designed for multi-role missions, air-to-air combat. The JAS Gripen is known for its agility and low operational cost. And of course, Dassault's got the improved connectivity, optimized radar systems, a lot of cool integration. Whatever they choose, they're going to have to look at, I think, operational maintenance as one of the key factors here. Because right now, the FAP has a diverse fleet. They've got fighters, transport aircraft, helicopters, reconnaissance planes, currently a lot of which are, as you mentioned, Soviet origin. So how are you going to best integrate this new fleet, these new aircraft, into your existing ways for operational maintenance, for the keeping things flying, keeping them repaired, maintaining these aircraft? I think that's got to be a really big focus, is possibly retrofitting or adapting the current operational maintenance systems to work correctly with these new aircraft you're adding in.
I think you were digging a hole for yourself there, but I think you've dug yourself out of it. So I thought you were just going operational maintenance, which is spot on, but I'd argue the key challenge was keeping them flying. To do that, it's integrating such a diverse fleet with new and legacy systems and managing maintenance across multiple platforms. So you kind of went there in the end. So yeah, but that just a singular focus on operational money, on saving money and time. There's a much bigger issue that you're going to be dealing with here, and that's combat readiness at all times without compromising on maintenance quality. So solution for that, I'm really going to jump in on a unified fleet management system. So critical threads. So use critical threads to integrate maintenance and operational data across all of the aircraft, ensuring efficient management of both new and legacy jets. And part of that is lifecycle management for mixed fleets. It is real-time maintenance and diagnostics, supply chain and parts optimization. You've got to bring all of that together in the critical thread, and then overlay AI-driven predictive maintenance. So you don't want to just be maintaining cyclic that anyway. You want to be using AI to really predict it, so you're optimized on your maintenance and use an AI for maintenance scheduling. So that's mine.
No, Andrew, we had a optimization pop up during that, which I think is just to put you on the spot here. Can you elaborate on the challenge of real-time data flow?
Yeah, absolutely. You've got these diverse aircraft coming in potential combat situations. How are you going to make sure that they've got real-time data flow with so many different systems on the go at any one time? So for me, it's what it's all about. It's how do you integrate all of that? And that's that single platform. It's that collaborative thread that's pulling that data through, depositing into the systems of the aircraft, so you're able to maintain and combat. If you're not in real time in combat, you're in trouble, aren't you, really? So there you go.
That's true.
Thanks, Paramdeep. Appreciate your question.
Yeah, great question. French defense giant Safran is set to open its first ever defense electronics facility outside of France. Not its first ever one ever, but outside of France. And guess where they're opening it up? India, marking a significant deepening of ties between the two nations. Obviously, we know that there's a lot going on in India. We talked a lot about last week. The unit is going to be focusing on producing sensors and then key electronics for military platforms, which is really reinforcing India's defense manufacturing capabilities, which they've been doing across the board. Safran's facility is going to be playing a vital role in supporting them, particularly also in aircraft engines and sensor technology. Additionally, Dassault Aviation has already secured land for a repair and maintenance facility for Rafale jets in Uttar Pradesh. Again, India is growing.
Really, really active in the defense space.
Yes.
The amount of partnerships that India's done very globally, I've got to say, not just necessarily US, but there's some Russian partnerships going on as well. Interesting. But change here, and I think ongoing really for India, and what a population of bright people there is out there. But it's technology transfer and integration for me. It's making sure the smooth transfer of advanced defense technologies, particularly in sensor production and the new material properties that are going to be coming over, and integrating those capabilities into India's existing infrastructure and ecosystem, industrial ecosystem, is the big challenge for me.
I think in a lot of cases here, we're actually on the same page again, which is weird, I know, for the show. But last week we talked about Dassault moving to India with an entire subsidiary, words are hard today, subsidiary working on just focusing on India as just for India, right? And now Safran is setting up a defense electronics facility there. So this is great and interesting news for India. And they're really wanting to work with the advanced materials and metallurgy, because one of the key to manufacturing critical parts of military and civilian engines is those advanced materials and metallurgy. So there's a lot of technology that has to be absorbed by the Indian industry here to have the knowledge of how to do all this, the forgings, the castings of key parts for aircraft engines. So I think figuring out how to integrate basically the entire product lifecycle management system into India's infrastructure and culture is going to be the key.
Okay. So Brian's answer is integrating an entire PLM system into India's infrastructure. Definitely important, Mr. Fence Sitter. But I would argue that really the bigger thing here is not just that PLM integration. It's about managing the broader knowledge transfer and technology adoption. That's the big one. I mean, we see that all around the world, but so I think that's the big one for me. How do we solve that?
Just to be clear, I said the entirety of PLM, and you said no, that's too much. So let's add to it and also add more stuff into that. Is that what just happened?
Not at all. I think what you didn't do is commit to the number one challenge and solution.
The number one challenge is, as Andrew said, everything.
It's the product lifecycle. I go, you need the product lifecycle, but what you really need is knowledge transfer and adoption by the local workforce. How do we do that is the critical solution for this one. And you've got to bring integration, operational alignment between Safran and India defense manufacturing capabilities. So you've got to have technology transfer management, use a PLM system to manage the transfer of advanced defense technology, make sure seamless integration of the sensor production and the metallurgy into India's existing infrastructure. Then you get into your knowledge and skill development, establish a structured knowledge sharing platform for me. You've got to get that. And then you've got your regulatory and compliance integration, bring all of that. But the real kicker that's going to accelerate all of it, as ever, is going to be AI enhanced knowledge transfer. So AI can automate and accelerate knowledge transfer processes by providing real-time support. AI assistance. So I'm there, I'm trying to learn all of this new stuff that's going on. I have a conversation with my AI assistants. They're pulling everything in from your PLM system using large language models, LLMs, even small language models. So it's giving me conversational help That's the best way to get your knowledge transfer going. That's the best way to get your adoption going, because then I'm in my own culture. I can talk, my language with something rather than going to another training course, which, you forget 90% within 48 hours anyway.
So the best way to solve this is an entire PLM system with AI integrated into it that people can have access to and share data in real time. So again,
on knowledge transfer.
That was the number one, was just everything. Yeah, no, I like it.
Just everything. Yeah.
Speaking of everything, we don't get a chance to talk about all of the news on this show, but we do get a chance to at least let folks find out about a little more than just the things that we talk about. So without further ado, how fast can you read? There's some themes happening here.
Yeah, there is. Number one, Rheinmetall is on fire. Every week seems to be talking about Rheinmetall. They are doing a lot. The one thing I'm going to say, I hope they've got a good mess mom, because the amount of deals that Rheinmetall's involved in now or have done, their production systems have just got to be A game every day, cranking this stuff out. And the other thing I think, it's support. I mean, India just busy on defense, huh?
We knew Airbus had already had a large presence in India, but they're growing. They're putting all their chips in, like everyone.
Safran, etc. Yeah.
A lot.
Even Philippines. I mean, Philippines was military last week. This week it's Cebu Pacific, commercial aviation. That place is booming. It's growing, isn't it?
Yeah. AeroVironment has hosted its first ever Defense Robotics Developers Conference in Orlando, bringing key defense robotics stakeholders together really to discuss innovations in these uncrewed systems, right? Senior executives from AeroVironment really emphasize the importance of interoperability, software integration, and cost-effective solutions for future defense needs. There's a lot of conversation around this market.
Except here.
Andrew, based off of DevCon happening here, I think that what we're really looking at is a collaboration, obviously, across companies, interoperability across multiple domains, streamlined software integration, cost-effective solutions. There are so many places I could go with this.
But don't sit on the fence. What's it going to be?
But I'm thinking that collaboration edges out all the other possibilities. I do. Because, even the president and CEO said DevCon represents the future of defense robotics by bringing together the best minds and fostering collaboration. We're shaping the defense solutions of tomorrow. So here we go. Even in their president says they're talking about looking at collaboration as what they think is number one. So I'm agreeing here. And I think when you're looking at multiple companies coming together, key defense robotic stakeholders, all of these folks discussing innovations in systems, helping each other out, how can you not say collaboration is number one?
Especially when you bring in that, well, the chief executive said it as well. I think it's valid collaboration, but I actually think the biggest challenge here is true cross-domain interoperability. Collaboration is important. Don't get me wrong. The CEO said it, not necessarily Bryan, who followed him. The real test lies in making sure that these diverse systems can actually work together effectively in real time across various domains. It's far more complex than simple, kissing and cuddling collaboration. It really is. So sorry, Bryan, I got to disagree with you. Collaboration important. It is about interoperability.
You can't have interoperability without working together.
So how do we fix interoperability? Cross-domain interoperability frameworks. That's the first thing. Modular system architecture. That's the other big thing. So develop a modular approach within the critical digital thread, allowing different robotic systems to adapt and scale based upon, mission requirements. And I didn't even mention AI. Did you notice? No mention. I think I've got bigger things to fry on that one. I think it's getting that critical thread working before you bring your AI in.
That's right. Boeing, you still mentioned it now. I thought you were going to go an entire article and not say anything about it, but here we are. Boeing has secured a U.S. Air Force contract worth up to $6.9 billion to produce small diameter bombs, SDBs. The deal includes I think under $400 million of that is allocated to foreign military sales to countries like Japan, Bulgaria, Ukraine. Production is going to take place in the heart of the U.S., St. Louis, Missouri, with completion expected by December 2035, so 11 years from now. The SDB, also known as the GBU-39, is a precision-guided bomb designed for high accuracy and minimal collateral damage. Each bomb can glide over 60 nautical miles thanks to the wings that it can deploy, and then penetrate over 3 feet of reinforced concrete. That's cool. That's awesome.
Manufacturing at scale. That's the big one for me. Ensuring you can efficiently produce that large quantity of precision-guided bombs at a low cost and on time to meet both U.S. and foreign military needs. That beat that, Bryan, beat that.
You're talking about SDBs here. SDBs are exactly the opposite of BFGs.
That's right. Yep.
And an SDB, but we're talking, they're small. So we're talking lots of them. And this contract's interesting because it had a guaranteed minimum and a $6.9 billion maximum, but we're not really exactly sure how many are being made. So it really seems like, regardless of what Andrew just said, the only thing that I can argue is number one here is for manufacturing at scale.
Well, hey, there you go. Right. It makes sense. It does.
To add a little bit, it's got to be manufacturing at scale that is low cost, that is accurate, that is precise.
Okay, that's exactly where I was going to go. So, okay, you got in before me. I agree with that. So the solution has to ensure Boeing can meet those production targets. You're right. Maintain your cost efficiency, maintain your quality all the way. How do you do that? For me, get your supply chain, because they're going to have a heavy supply chain on this, supply chain production framework, end-to-end integration. Got to bring in your traceability, obviously, for the quality side of things. This is a big challenge, and I am going to overlay that supply chain integration all the way through to your lines, through to your production. And the best way to do that today, I think, is overlay your manufacturing operations management and supply chain integration system with an AI-driven production optimizer. It can continuously monitor production processes. It can identify bottlenecks and adjust your schedules in real time, or your workflows. So you've got kind of AI APS going on. Then you've got to get your predictive maintenance running, because things break down, and you want to be maintaining them when they need maintaining, not just, again, cyclical. I managed to say it this time. I'm pleased about that. And automated quality assurance as well. So get that supply chain, mess mom, AI over the top. You've got it. You've got a great system going on. It looks like.
I think we got a comment here that you've answered somewhat, which is, what are the challenges you see in large scale manufacturing in this context? I want to add, before I let you dive in even more, I want to add, I think one of the most interesting ones is, you've got to manufacture a lot, but you don't know exactly how many. And that really plays into what's happening, because you've got to predict how many to make in order to do the right purchases, the right cost savings, the right everything you need to do, but not make too many, not have waste. And I think that's honestly probably a kind of area where some of the AI modeling can also come in. But let's let Andrew dive in on what these challenges are.
Manufacturing at scale is honestly such a huge macro issue around the world, because we've been spending millions and millions and billions, if you will, on design and engineering. Manufacturing has traditionally been neglected for the last couple of decades, if not longer, quite frankly, because we've been offshoring all the time. Less so in defense, admittedly. So manufacturing at scale, it's that supply chain integration, because you're not building it all in-house. You're not vertically integrated. You're using a supply chain. So those guys have got to be involved at the design end, collaborating on that. Then you've got to simulate the whole production and making sure your suppliers are involved in that process. Then you've got to have your MRP systems working with your supply chain in your warehouse. But then ultimately, once it's hitting that shop floor, that agility for inevitable problems in the supply chain, so that you can adjust your lines, adjust your plants on a global basis, never mind just domestically, that can be going on. Manufacturing at scale is consistently the biggest challenge we find for startups and the large kind of blue chip firms that are out there. It's that readiness for volume, is getting it all digitized. I mean, we were in a great conversation with a customer yesterday. They want lights out. They want a lights out factory. They want to dehumanize, bring robots in, have AI running all the time so they can just produce. So I think it's just such a big area. I mean, I can go on for a long time in this one, Parandeep. Manufacturing at scale is consistent. Where do you start? For me, get your design, get that built in, get your suppliers built into your manufacturing. And that means you've got to have a MESMOM layer, because that's your leader for your factories. That's your start point. Everything after that, yeah, there's lots more to follow.
I think that, manufacturing is something that has been happening for a long time, and it's still not completely figured out yet. And I think every time we have new technology that comes in and new software that comes in for the other aspects of the product lifecycle management, it actually, I think, needs to integrate back into and figure out how does our current manufacturing or changes in manufacturing need to operate with these advancements everywhere else. And sometimes you're right, that's kind of the overlooked area.
Because it's the most risk averse area of an enterprise, because you mess up when it's down there, it can be costing you thousands and thousands per minute for downtime. So that's why it's really risk averse, and that's why it's not shifted with the times necessarily consistently around the world, because of the risk of downtime.
And this next thing Greg's going to talk about has nothing to do with risk at all.
Yeah, no, none whatsoever. Embraer has revealed a futuristic jet concept that would fly itself using AI without needing a cockpit or pilots. The cabin itself is redesigned to look more lounge-ish, offering passengers a pretty luxurious, relaxed experience. It's really conceptual right now. There's no real plans to build a prototype or take it beyond the drawing board anytime soon.
Right.
I mean, of course, reactions to this vary. Just look at Andrew and myself. We're going to have very different responses to this. But known for its cutting-edge jets, I'm kind of excited to see what Embraer is doing with this.
I mean, a plane without a pilot or a co-pilot or just a lounge is where we expect to see the stuff that's flying this thing to be, and now there's just a lounge there. I'm not sure I'm ready for this. Andrew is. I'm not sure I am, but fortunately, Embraer isn't quite ready yet either, because as you mentioned, they're not yet building it. They showcased it, and they're saying that this is very likely what flying a private jet could look like in another couple decades. There's no prototype yet, so we're speaking completely theoretically here, but not sci-fi theoretically. We're speaking like real theoretically. So when this project starts, it's all about the innovation. How do we make this happen? Because we've seen complications of autonomous stuff and no driver on the ground. Again, air, whole different story. And so I think for me, this really is looking at the innovation inside of your design and change management.
I don't know. I think there's probably more fear about autonomous driving on the ground because you've got so much stuff coming at you in real time. So many things. Where when you're kind of up in the air, we're already doing it, aren't we? Really, you're sitting in the back of the aircraft. You don't know whether the pilot's controlling it or not, quite frankly. And a lot of the time, it's on autopilot once they've taken off and landed. So I think we're kind of almost used to autonomous flying. But for me, how do we make this real quicker? So it's innovation readiness. That's the biggest challenge for me. The solution, if you're going to be innovation ready, if you're going to get this really up into the air quickly, it's going to be AI powered virtual simulation and testing.
So Andrew wants us to use AI to make AI. Isn't that the plot of every sci-fi horror film ever?
I think so. Yeah.
I think it is. AI would enable Embraer to optimize design, perform risk assessments, preemptively solve potential issues, accelerate, therefore, the readiness of that innovation without needing lots of physical prototypes, which are going to cost lots and lots and lots and lots of money.
Yep.
In other news, the Seraphim Space Accelerator, where I'm sure they're having more of these conversations, focused on early stage space tech startups, has unveiled the participants in its Mission 14 cohort. Since 2018, Seraphim has supported 109 different companies across 30 different countries, helping them raise over $540 million in funding. I mean, this year's cohort, including startups from 7 countries, new participants from Saudi Arabia, Chile, and Turkey. There's a lot of global interest in space tech. We see that across the board. And the companies in this cohort are working on innovations in areas like satellite-based internet, AI robotics for space infrastructure, sustainable solar power for space exploration. There's a lot going on.
We've got a company here that is finding and supporting early stage companies through every stage of their journey. Which sounds like they're taking a close look at the business practices and the plans, and probably having a really solid take on how product lifecycle management in its entirety, fits into what your business plan should be. How does this change your business? How does your business plan modify your PLM practices, and vice versa? And by bringing in companies, globally around the world, I think that we're really not only looking at all of that and across cultures, across the different business practices, but when really looking at the key areas which you need here, the data analytics, the Earth observation stuff, the advanced manufacturing, I think that the number one thing I would be looking at is what requirements do I have to meet, and how do I make sure that my PLM and business support these for the goal of my company, while the fact could very well be that some of those requirements aren't even actually fully defined, but I got to be prepared for them to be.
Yeah, that's a good try. I've got to say at the number one. No, your requirements is critical. I agree with that, and I think it's the last piece that's really the number one, which is flexible enough to ensure scalability as the companies grow and face different markets, different regulatory environments. So I kind of agree with you again. It's just getting really consistent these days. We need to fix this.
We need to stop agreeing.
Yeah, I agree.
You know what, Andrew, you're wrong. Requirements are not important here at all.
critical thread, requirements management and scalability within PLM. So the most important yet to speak to that is going to making sure that they're well documented, making sure they're traceable, scalable to meet market regulatory needs. PLM will need to enable these startups to manage their entire life cycle. How do we overlay that? We're going to have AI-driven requirements alignment and forecasting. So I think if you bring that AI engine again over the top of it, it's going to help you predict as you go forward, analyze market trends. You can feed that in there, analyze regulatory shifts globally and technical data. So again, it's your large language model that are going to come in, feeding these designers these requirements so that you're able to adapt as you go. AI, guys, you can't deny it, is going to fix this one, make it really impressive.
I mean, it should definitely help to predict and prevent problematic production issues.
Yeah. I don't like
that stuff up.
I don't like how much you two are agreeing with each other. So
yeah, I know.
back to your corners. Yeah. Let's take a quick break and maybe we'll get back at it. I know we talked about it a bit last week about Embraer's automatic takeoff, and sounds like they're expanding that to more commercial use. But I think they're just going to keep running with that concept. Talk about the fully AI plane that they're making.
They're at the cutting edge, aren't they, Embraer, right now? They really are pushing those boundaries. The other thing that is pretty noticeable, if you look at that kind of around Ukraine, those countries are on our edge. There's short-range missiles going in. Lithuania was just mentioned. Poland just mentioned. Ukraine's definitely keeping us on edge. Well, it's not really Ukraine keeping us on edge. It's Russia keeping us on edge, isn't it, quite frankly? And NATO modernization, etc. That's a lot of deals going on around there.
Yeah. FDH Aero, speaking of deals, has signed a new multi-year contract with China's AVIC XAIC to support the COMAC C919 passenger jet, which is really designed to compete with the Boeing 737 and Airbus A320 that dominate the market right now. This deal is really strengthening their role in the supply chain, offering new product lines, just-in-time delivery services, managed by on-site personnel, right? The C919 itself has already received over 1,000 orders, which is huge, gives China a real competitive edge in the market.
I mean, we're looking at, 1,000 orders is a lot. Mm-hmm. And we're talking about FDH's role here in the supply chain. And when we look at the supply chain, I think it's important to remember planes are generally made from a variety of different suppliers who all have their own supply chains they're working with, and then they've got to supply the parts that get assembled on the plane. We know that you mentioned AVIC XAIC was one of the major sub-tier supply companies that does the work of the wing assembly and the mid-fuselage for the C-19. We've got multiple companies that are sending parts that have to be assembled in the final parts of the aircraft. So one thing that all these companies really have to consider is their IP, the data that they're sending, because you have to know, how am I going to take these parts and assemble them with other parts that they have to connect to and work with, but without necessarily giving away all the IP inside of any like proprietary stuff that I've made, in engine work and any sort of these operations. And so there's that to look at. So sending those boundary representation models, removing the IP, in addition, making sure it meets all of the necessary requirements for flight. I mean, weight's a huge one for anything that goes in the air. And so all of this has to be taken into consideration when you're looking at those factors of, if I want to build a plane or a wing even, and I'm using parts from different suppliers, how do those fit together? Do they all integrate together? Because I might have one option of a configuration that does not interact with other options that I might put from other suppliers. So trying to simplify the supply chain is something that's needed, and it can save lots of money, but it's a lot more difficult than folks often think.
Yeah, I'm with you. I'm with you on this one. I think we're ultimately, I'm going to go back to kind of good old Elon's saying, which is manufacturing is 1,000 times harder than design and engineering. Absolutely. I think the Chinese are pretty good at manufacturing, so to speak. They throw a lot of bodies at it, and they've got a lot of good systems out there. But I think what's interesting now in the airline side of things, the aerospace side of things, is that supply chain piece. Yeah, once they've got it into the factory, they can manufacture at scale. They're pretty good at that. But it's that supply chain integration. It's that data sharing, to your point. But I think it's actually data synchronization, real-time synchronization between all of the moving parts in the supply chain. So I kind of agree. But the critical issue here is not just that data accuracy, it's the ability to manage the complexity of the supply chain in real time, ensuring that the parts from the different suppliers arrive on schedule and fit the precise requirements of the final assembly. So what do? AI.
Definitely not AI. Oh, he said it.
No, it is. End-to-end supply chain management, absolutely. Just-in-time principles overlaying on your supply chain into your mess mom, continuous traceability of parts and their specs, but bringing an AI-powered supply chain optimizer for me is going to be the big thing. So tracking, reading, if parts are coming in out of sync, the ability to adjust to another supplier or to adjust to an aircraft is going to be key to this. So the real conductor is an AI supply chain optimizer as a solution for this. And we love that stuff.
No, I figured it out, Greg. The reason why Andrew likes AI so much is because for the previous, until maybe 5 years ago, when he used the word AI, it just meant Andrew intelligence.
Oh, okay. Yeah.
I wish.
That was AI 1.0.
Minus 1.0. Yeah.
I mean, if Apple can can put Apple into AI, I guess Andrew can put Andrew into AI.
It's
right?
true. It's true.
Good point. Yeah.
I'll take Andrew over Apple any day.
I don't think anybody's buying that. There you go.
That's right.
Yeah.
HII's Mission Technologies Division has been awarded a task order to develop advanced autonomy and navigation technologies for the U.S. Air Force and Department of Defense. The research is focusing on 3 key areas: autonomous systems, non-GPS precision navigation, and robust global navigation satellite systems. Obviously, I mean, the project is going to be conducted at the Air Force Institute of Technology. The work aims really to address challenges in GPS-denied environments, which is going to enhance that, warfare navigation capabilities. It's exciting work that they're doing.
Yeah, so there's the challenge, isn't it? It's designing and prototyping for GPS-denied environments. So developing reliable autonomous navigation systems that will function in that kind of environment, or even in compromised setting environments, making sure that it's all seamlessly integrated into their defense operations. That's the biggest challenge for me.
Unlike the theoretical concept that we had from Embraer earlier, this project is one that is currently being prototyped and being developed.
Yeah.
And it's going to have all these stages happen, and you're going to have the autonomous systems. You're going to have these all having to work together cooperatively. And as you mentioned, it's in that non-GPS navigation. We used to actually navigate without GPS. There was a time in history where this actually happened, but now we're so reliant on it in so many things. I mean, we just start driving and follow the instructions of the magical robot in our hands, right? So the ability to function in a non-GPS environment is going to be huge.
Mm-hmm.
And this means a lot of design, a lot of change, a lot of innovation. So I actually think that prototyping is my number one, and feeding that into that loop of design and change. So make your prototype from your design, figure out what works and doesn't, change it, innovate some more, make it again, rinse and repeat. And of course, these don't all have to be physical prototypes. They can also be digital prototypes for some of these phases to help on cost and on some of the savings. You got to have a combination of all of it.
Yeah. Okay. I agree with Bryan. There's a significant kind of gambit of innovation at play here, but the prototyping, but the focus should be on how quickly these systems are adapting and improving through this kind of iterative testing in real world GPS denied scenarios. So that, on top of that, so agile prototyping and testing GPS denied environments, one solution. 2, real-time simulations of GPS denied scenarios, and 3, continuous feedback loops. So all of that needs to be going on in the testing, simulation, prototyping piece. And then putting your AI in there. Again, you're going to have to accelerate it. You don't want to be rebuilding prototypes. You don't want to just be simulating. Let's bring in AI models that help you iterate faster. It says, no, that one ain't going to work anyway, without you having to even simulate it. So AI-driven autonomous system adaptation is going to be biggest solution for me. So it's going to accelerate it. The algorithms can be used to predict environmental conditions, adjust navigation strategies in real time. There you go.
There's still a little too much overlap, and you guys are agreeing a little too much. So I'm hoping for the last official article that you guys are going to come in and disagree. And
we need to put on our disagreement boxing gloves here.
Yeah, put on. Yeah. Maybe we'll see a fight here. I don't know. Romania has selected the Turkish-made Cobra 2 armored vehicle for its land forces, purchasing over 1,000 units for just under $1 billion. The first 278 are going to be manufactured in Turkey by Otokar, and the remainder are going to be built in Romania through a number of different local defense companies. Obviously, Romania is looking to modernize its military. It just recently purchased the K9 Thunder howitzers. The Cobra 2, I mean, look at that thing. It's a 14.5-ton vehicle, can carry 11 different personnel, features 360 horsepower turbo diesel engine. This thing is cool. I would like a ride. Yeah.
I think you're right. It's pretty darn cool and can do a lot of really cool stuff. But we're talking about 1,000 of them.
Yep.
278 made in Turkey. The rest at plants operated, Romania and local companies.
Yeah.
I think one interesting thing before we go where Andrew knows that we're going here is that the Romanian ministry has attached a lot of importance to foreign suppliers' offers of cooperation with those local defense plants. So the tanks, I think last week we talked about 54 howitzers from Hanwha. All of this stuff that's happening is probably due to the war between Russia and Ukraine, right? And Bucharest now needs to strengthen what's been an undersized and neglected, basically, Romanian defense industry. So in order to do that, you've got to build a lot of them, make sure they're quality, but build a lot of them, which means scaling. I'm going for scaling as number one.
Number one challenge. Okay.
Yep.
You want to take a run at solving that problem?
Well, I mean, are you agreeing with me first? Is that what you're saying?
I think Yes, because you added to it again just to cover your bases. You're right. Manufacturing at scale is absolutely correct. But the real challenge isn't just at scale, but then you added onto it, which is making sure you've got the same quality and efficiency as the Turkish operations. So that integration of local defense companies into the supply chain is going to be critical. Without careful oversight, the scale itself could lead to quality issues.
And I'm thinking that the way that I would tackle this problem before looking at things like AI would be to just look at what is my mess mom solution here? What do I have going on? And how am I, of course, integrating that with everything else?
Yeah.
But really, you've got to have a good mess mom platform set up to even start doing any of this.
And the reason why is that there are standardized processes in Turkey. They're churning out, what is it, 278, I think you said. They're going to be turning that out. So there are standard processes, there are standard sequences, there are standard quality gates along the way. Lift it, shift it, drop it into Romania. So you want that. And the only way to do that is a mess mom. So, because if you put in what we call business process management, that allows you to scale those processes across multiple plants, to manage them centrally, to make sure the quality is in place. So I agree, mess mom is number one. And then implement continuous oversight feedback loops to ensure that the Romanian manufacturers are going to meet those timelines, as well as maintain the quality standards for these Cobra vehicles. I can take it to another level, definitely, and that is AI-powered manufacturing and quality monitoring. That key AI solution we'd bring in would be to use AI-driven production monitoring to adhere to strict quality controls and production schedules. That's really going to make you agile, no matter the circumstances and the predictions that you're going to have coming at you as well.
Greg kind of gave us a hard time over these last 10 articles about agreeing too much, but
way too much.
When you think about what's happening inside the product lifecycle management, you've got all these different pieces that do have to play together and work together. And so even when we disagree, we still are agreeing on things that are important and that often you can't have one without the other. It's like, we kind of are saying, what's our number one issue with this, or what's the number one thing to fix? But in reality, and we joke about this, the answer being everything, but the answer for most of these really is everything.
That is the whole point of the critical path along the digital thread, critical thread. Eradicate silos, eradicate manual systems. Hey, you can't do it overnight, but over time, through a digital transformation roadmap, you're going to be able to integrate end to end. So when something changes on the front end of design, it hits your lines with reconfigured lines to adapt to those reconfigured design changes. So you're right, it's end to end. Everything's reliant on predecessors as well.
And there's one thing that's happened, huge piece of news that we haven't even talked about yet, which everybody knows. And that's it's happening basically in space. And this is when I was flying back from a client last week, out of the airplane window, I saw this.
Oh, yeah.
That's beautiful.
That's cool. I've seen a lot of that on LinkedIn, guys flying over Ohio and seeing those Northern Lights. I've never seen the Northern Lights. I'm envious, man. I'm envious.
Yeah, this was just outside. The pilot announced it, and like the plane tilted to the side as everybody tried to go.
Your shot? That's your shot as well?
Yeah.
Wow.
Now,
nice.
Bryan, I know photos don't often do justice to actually seeing it in person. What percentage would you say, yeah, this is a cool photo, but seeing it in person?
Honestly, the photo's actually cooler because that was a 3-second exposure and you got to see the vivid colors.
Okay.
Naked eye, it was a lot more muted.
Okay.
So in this case, the photo was actually cooler.
Wow.
But I guess I should also admit there is something possibly even cooler in the news that did happen this week too, which also is in space. And I'm sure we've all seen it, but I just got to play this because this is amazing. Like,
I've never seen the actual. I've seen little bits as I've scrolled through social, but wow,
this is one of those moments that is probably going to be monumental in the history of what happens in our society.
What SpaceX has done with space industry is really revolutionary, isn't it?
The fact that it's
everybody there too. I mean, these are some excited folks.
Wow.
Yeah, the fact that it slowed down that much, I mean, that's just a cool thing. To give you guys a little bit of, I guess a good idea for the size of that thing. Think a 10-story single family home. That's about the size of
that 10-story single family home. Okay.
Yeah, that's right. It's a really big, it's a mansion, but they built up. So
I think there is one in Mumbai. It's like one of the richest guys in the world. He did build a multi-story family home. It's crazy. Yeah.
I think the average family home is around 40 feet. This was about 30 feet in diameter. I only know that because my wife is an appraiser. So it's cool. Elon Musk said it's science fiction without the fiction, and I think that's pretty.
That makes sense. I mean, I know that somebody on this is probably going to make fun of me for saying this, but it reminded me of that moment in Star Trek when they had the first like warp drive flight, which is what caused the Vulcans to even notice humans and be like, oh, we're going to talk to these folks now because they made this technological advance. And then that's where the whole Starfleet was. Like, that was the history of how space travel and exploration happened. I kind of feel like this is similar. I don't expect to see a space elf coming down and saying, hey, good job, maybe. But I do think this is one of those moments that, history will look back on and say that really changed a lot of stuff. This is a huge success. And we've talked a lot about Elon Musk and SpaceX and his other companies, but about their good handle on a lot of these manufacturing and product lifecycle management processes. I don't know what the number one is here because there's a lot that has to go in to make stuff like this happen. And it's not just throwing money at the problem, because people have talked about how, well, he's a billionaire. He just kept throwing money at it till it worked. But there's other billionaires out there. They haven't done this yet. So, and they've been trying, right? So there's something going right here. And it's a monumental show of just human engineering. I'm sure AI was probably involved too, Andrew, but what we've done is not I didn't do it, but it's really cool. It's cool. That's all I'm saying. It's cool.
Love it.
And with that, we're at the top of the hour.
Let's get out of here.
We're not going to let Andrew talk about AI anymore. We're just going to say, everybody, thanks for joining us.
Have a great week. See you next time. Next week, same time, same place.
And we're out.